This is an overview of Views Tools Morpher, and we are going to see like overall what it means to run with the Morpher, and how you can go ahead and edit some parts of it and contribute to the Morpher. So the first bit is this is the repo, so you can clone it here, and once you have it in your folder, let's have a look at a bit at the file structure that it has. So when you run Views Tools on your project, let's have a look at a sample project here. When you run Views Tools on a project that you set up with Views, you will get this command set up for you, right? So this goes ahead and runs the Views Morph CLI, which is the main export of this project, and it looks at a folder, then it runs in a watch mode and tells it to render in a way or another, in this case as React DOM. So how does that actually work? Well, we have a CLI, which is the entry point of Views Morph. This CLI parses a bunch of options, and as we said before, the most important ones are around that. You can use it to like morph an SVG, run as like morph the end-to-end tests and page objects and a couple of things like that, or morph to React Native. And you can use it in watch mode, like we use it here, or just as a once-off. So the starting point is here. This is where we parse the options of the CLI tool and the command line tool, and then we have here a couple of other things. They say when we are on watch mode, basically we call the watcher and we tell it that it should just run, and then otherwise we go, if you are passing down a directory and you are on a once off, we call it also watch because that's the entry point really, and then we just say that we just do it once, and then a couple of things here when we just want to do one file. So after this, we go into the watcher, right? That's the next entry point to Views Morph. And in the watcher, what we get are a good few things. It's quite a long method, which needs a bit of rework, if someone is interested in this, by the way. What happens on this is that we do file watching, basically. So towards the end of it, we have a Chokidar process that will just run and pick up new files as the user goes, doing things. But actually before that, I should have said that before, we actually have where we go reading all the files that exist today. So we first pick up all the files, store them as views on this through this mechanism of like adding views, skip morph. So let's actually follow that. That's actually calling add view, and then here we have a wrapping function filter to just filter the type of files that we get. That you can see actually filter here. It basically just filters stuff that we don't need. So now add view again. Add view just basically checks a couple of things around the view, that that it doesn't exist again, and that it's not a reserved name. You can name one of your views vertical, for instance, and then a bunch of other things, and then it puts the file in a bucket where it kind of belongs for now, which is, we understand, logic files or views files in this point. And it also tries to make a fake view for a third-party component that you might be integrating into a trusted file. So it gives you a bit of a signal that it's doing that. If you run it in verbose mode, that's something that you will find in a good few places. And if it should morph the file at this point, it will do it. On the first run, we don't morph all the files. The reason for that is that we want to actually gather all the files first, and then once we have all the files, we then need to understand the structure of the links between those files, and that's the point where we actually do it. So once we are ready with them, we do morph them. First of all, we get the source of those files, meaning we literally get the content of the file in a way, right? And when we get the source, we also parse the file with the views parser. So the views parser is where most of where everything actually happens, in the view, and we're gonna see that in a minute. And then like the next of the rest of the processes are after a view gets parsed, we go ahead and morph them, right? So essentially we have the parsing aspect of it. We get the source, we parse it, we morph it, and morphing it, let's go into that method. Morphing it is also a method that gets called on the file watcher when there is a change in a file or when a file gets added. And in here, we just go ahead and check and try to run the morph method, which is also one that we're going to see in a minute, where we tell it how it's going to be morphed and a bunch of other things that we just pass to it. This is even when we do things like dependency resolution. So for instance, this morpher gets past a get import method that then we use to follow make get import. Then we use to actually return the actual import that we are going to do based on the views that we have detected and so on. So grand. So now we are on get import here, and once we are done with it, we create sort of a payload of a morphing payload. We do a couple of things here around the maybe it's ready is like a first method, not to kind of go when you're first run the morpher. We wait until everything is ready to just return on the overall promise that we have at the top. And then once we are good here, we do here as well, something like we remorph dependencies that we have on our view. So for instance, if some file depends on this view, we just say, okay, you may want to update that basically, and that's a handy mechanism that is there. And this is also important because sometimes we would have, say, a logic file, and as you would know in views, we have the view file, and the logic file can sit on it. And when another file uses that view, so say we have, let's make a sample file, so we have something like this, and we have A, say that is a view, right? And then inside that we use B, right? So say B actually has a logic file that depends on it. When we call it at this point of use, we are actually using the logic file of B, not just B directly. So we need to tell A to go and restructure itself so it picks up the logic file instead. That's more obvious when you start using the morpher a bit, I guess. And then once we are done with that, we call this function on morph, right? That by default is write into a file, as we can see here. So there's a bit of a function outside that will just write a file to a JavaScript file. And you could hook this to some other mechanism if you want it, but that's the gist of it. So now that we saw this, we have 3 steps then, as I said. So we have the parser, the morpher, and then we just output it. So the parser gets the text file gets the text content of a view, and returns back a bunch of tokens that we can use in a better format. So it's like an abstract syntax tree in that regard. And it's a very long method in a way. But overall it's not necessarily like there's not a lot of stuff between it. So we have 3 sort of main things in here, I guess. Let's see, let's go at the top. So when we start, we just make sure that we get lines. So essentially we parse the text, we split everything by lines, and we just end up with like a set of lines of code in a way, even with the empty lines, which is what gives us our proximity nesting. So then at some point we just iterate through the lines towards the end of this, and we just say, okay, if I have a block, go ahead and parse the block. Otherwise, like, check if we are at the end in a way, and if we aren't, then just kind of like get that block outside of a stack. A concept that I should probably explain here is that in views we have this concept of a stack of views. So essentially, while we go picking up and understanding that there are views that were parsed, we go pushing them into a stack, and then we just go getting them out of that stack to create the actual views at some point. Now, generally speaking, your view file will have one view, right? But it might be the case that you went too far with one top level view, that you went too far and you actually inserted too many proximity nesting bits, and then you end up with too many views. So this will also give you that, which is handy because you can use that to debug and understand perhaps that you did you went too far with the proximity nesting and stuff like that. So that won't render. So once we're in here, the first method that we call is parse block. Parse block has a bunch of things. This one we start constructing the AST. An AST really in this case generally has a type of a node, right? And then a bunch of properties that describe it. And a block has it always has a name. It may have it has a block name really, and then it may have like a way that we call it, which is the is that we refer to. So in Views, when you do like vertical, the name of this block in this case would be vertical, and then we can go like a vertical, and this would be a block that is referred to as is, and is would be the a part of it, right? So once we're in here, we also understand a bunch of other things, like whether this is a capture or not, if it's a list or not, and a few bits and pieces like that. If it's a group as well, this is probably the most important, and then also whether the block is a basic block. And that's a good point perhaps to introduce the helpers. Helpers is another rather long file as well, and here we have a bunch of checks that we do, right? And amongst those, probably the first one that we found just now is whether this is a basic block or not. Most of these checks are just comparisons on regex. So we have a regular expression here, like what is a basic block, right? So a basic block, and we do a capture group where we define all the basic blocks that we have, and you can see all the usual suspects here, like vertical, text. We'll find horizontal, all the basic blocks that we can potentially do in Views. We also define how we understand what a block is, right? Like if you have some doubts around the regex, it's just give me a shout and we can go around them. Basically, a basic block is anything that starts with lowercase, with an uppercase letter, and then is followed by any sequence of letters and numbers. And after that, there is space, and then we have potentially like a second part that is exactly the same type of regex, but what it gives us is if that value is defined, we get a type, and that's it. So then once we're here, we check whether the block is basic or not, and we do a couple of checks. This one is when it gets a little bit messy. There are a few warnings that we go pushing here if you did something that shouldn't be there. Like for instance, lists in Views can take basic blocks inside. You need to provide a view inside of it. So if we detect the basic block inside the list, we tell you that you should actually be using something else, and we push a warning to a stack of warnings that then we display on the watch process. So after that, we do a bunch of other checks, and sometimes what we do is we go pushing things to children, so to the children of a block in a way, and of stack in this case, and that's what we do. So right, so after this, what do we do? Okay, so at this point, then this is how we tell that a block is a group. By group we mean something that has other things inside. Like in this case, groups are things. Actually, I don't need to remember that. We can see it on the helpers. So we do have things that we don't say what is a group. We say what is not a group, because your view is also a group, right? If you make a view, you can pass things to it, but I won't go too much into detail there. It's like props children on React. So, but things that are not a view are image, text, special one proxy that we're not going to discuss now, and then most of the SVG bits, and that's it. The ones that are not groups are the captures, like say capturing email, text inputs basically, and so on. So things like vertical, horizontal, the SVG holder, list, and a few others, and your own views are all groups. So once we are here, then we just start pushing blocks to a stack, and that's how we start constructing it. The best thing I would say if you want to understand that is to actually put a debugger and start going through it, right, and see what happens on a view. So after we parse the block, we go ahead and parse the properties of that block, and this is this method that is like quite extensive in a way. And what we do here is we try to understand what is the end of the block in a way, and we understand the end of the block when we actually find that either there are no more lines, or that we reached another block. So a block is like the configuration of a block is adjacent. It happens next to each other. Then we set up a bunch of things and start iterating over the lines of props that we have. We start distinguishing a few things, right? So we have two types of props. Well, not two types of props, sorry. Two types of lines that we can see at this stage. And one would be an actual prop, and the other one would be a comment. There is a mode in the morpher that allows us to skip comments, and we mostly use it on the morpher itself. When we pick it up, we'll see that later. Comments are valuable because they, of course, they are part of our code. So we treat them as a special thing. And then when we are inside the prop, a bunch of things happen here. Probably the most important one is that we understand and we get the prop itself. And here we get a bunch of other things if they do happen. Like, let me go in here. So like things like whether, okay, is this a slot, right? And if it is a slot, then we start sort of like extracting the different parts of it, whether this is, we tell, yeah, it's a slot, and actually it's a negated slot, right? And then we pick the name, and then at some point we just understand either what is the default value or the value of the slot itself. So with all that, we go to create some tags, right? Which is the next step here. And the tags themselves tell us certain things about it. For instance, whether our line is a style, and then whether we have you've entered an unsupported shorthand. Like for instance, you wrote padding, and we don't support padding. We support padding top, left, bottom, right, and a couple of things like that. And then whether the block should be a slot. That's also important. So a block should be a slot if it's something that doesn't make any sense, that it takes anything that is not like a function or an array or something like that. So for instance, in this case, or like in conditionals, like in whens. So whens, on whens, focus, click, from, basically anything actually that is on. These regs actually like clashes with these guys, but we put them there because they are the ones that we actually know of, we are certain. You can add probably more. All of those have to be always props, and then we actually tell whether the slot is valid or not, because you may have invalid code in there. It's hard to write invalid code here for the most of it, but you may have it. For instance, if your view goes something like when, like this, well, that's invalid for when. And if you do like this, well, that's also invalid for when. So you need something in here at all times. So that's that. At this point, we print a few warnings, if that's the case. Then we start understanding the scopes of a block. That's very important. So the scopes are done through whens, and we distinguish two types of scope: system scopes, which are things like hover, focus, disable a few others, and then placeholder, for instance, which are sort of comparable to pseudo classes on web, right? I'm saying sort of because there are things like that don't apply on native, like say hover, for instance, and things like placeholder that they have a different treatment when we go into an input in native. So in here then we do a bunch of validations again, that we warn you if something doesn't feel right, and at that point then we start constructing the actual scope itself. The scope's name goes after the when, so the when line determines the scope, and scopes most times are just like, as I said before, it's like boolean that turns something on or off, really, like a set of properties. And once we are past that, we just say that we sort of enter scope in a way, and then we at the end of it we still construct the property that we are after, which is part of the ASD. So if you can compare that to the block that we saw above, and that's just going to be the same. So we start doing that. We get the actual value at the end of it, and that there's some cleanup happening on that, so far as I remember. And we cast the value, so we get the real thing, like whatever data structure we need there. And then we do let me remember this bit, a couple of other things. So yeah, sure, we put a default value. So if you use a slot, right, so if you have something like, I don't know, text like this, right, hey, what happens here is that this is your default value. Now text can actually be empty, it's okay because that's empty default value. Now, if you did something like I don't know, padding top like this, right? This will warn you and it will say, hey, you should actually add the default value for padding most times, and that could be 0. That's fine, but um, like that's what it sort of does anyway. And then these default values are actually default props that land on your on your React component, and we're going to see them when we get to the morpher. So at that point we say, okay, if we are in scope, then we are going to be pushing, and we don't have a prop like that already. We are just going to push it to the open, what we call them, the open slots in a way. So when we use a view, we can do some inference and understand what kind of goes there. So that's almost it in terms of the parsing of it. Then we have a bunch of other things at the end, like setting just the line right and a couple of things like that, and we just push either to the scope properties or to the properties of the block. We push the actual node that we just got. Once we are done with this, we start sort of decompressing the stack in a way, and that's how we create the final view. So that end method basically does some housekeeping around that, and it also understands things like yeah, a couple of things around it that you will just find handy. And then this is when we have an empty stack at the end, we actually push a view in a way. So after we do that, there is actually let me just find this here. So this method, that's the last one that we have in, and when we finish doing stuff with the blog, we have all the properties that it takes. We can understand whether it has a font family or not set on it. Most likely will. So that's when we go to look for fonts, and this is where we understand actually the fonts and the weights, and we like export that. So then we can use it when we compile it, basically. So that's it with the parser. At that point, we are done with it, I guess. So the next step is the morpher. If we go back to our watcher, we're going to see that at some point we were calling the parser, and at some point then we call morph. And morph is one of the methods that is actually exported on our index.js, and it does a bunch of things here. So morph calls actually the actual morpher. Then it says, okay, if I'm supposed to compile the code, it runs it through Boublet, so we get like the transpile code of it. And then if you would request it that the code gets prettified, it runs it through prettier. So let's have a look at the parts that are actually within views, like the morphers themselves. And here's what we have, the actual ones. This is the param that you pass on the command line, React DOM, native, or end-to-end. React DOM and native are pretty similar. I'm just gonna go through one of them, and so we can see like an overall the structure of how we go understanding it. Basically, what we do is once we are on the morpher, we define like state that gets shared across all the different like bits that go through the morpher itself, and then we go ahead and start walking the tree in a way. So for those that are not really familiar with ASTs, with abstract syntax trees, what we do here is we get a node and we say, okay, what kind of node are you? And we start passing like to certain bits that say, hey, I want to deal with this node, and then when there are children of that node, it goes into a children, and so on and so forth. And I guess the most important part is that we have a render array on the state, and that's where we go sort of throwing all the code that we go creating with React. There's definitely like a more robust way of doing it than doing strings here, I guess. Like you convert into another AST perhaps, and then printing that out like a React type of JavaScript AST. And we are super open to contributions if somebody feels like that's something you would like to do. Now, what happens inside walk? So let's go to that. So walk, we go here, and walk looks like very sort of abstract in a way. It literally goes and says, okay, a node can be in the concepts of ASTs, what happens is that we have a node and it gets visited, and the visitor goes in and out. So that's when we have these enter and leave mechanisms in a way. And we, in this particular version of this implementation that we did here, this walker expects both enter and leave to be arrays. It's just for simplicity, really. And then we, as we said, we go in between them, in between entering and leaving, we go through the children, and we just always like call visit on them. So once we're here, let's see actually how we call walk. So we said before we call walk here, and we pass, we said a visitor. So what is that? That's actually in the React DOM block part. And this is when we start converting the block in a way. So for instance here, this is the entering of the block. And the first bit that we do is we set the test ID of the block, for instance. Let's have a look at that bit. So this would be here. Most of the files are actually on a share folder called React, and then when there are specific bits, they sit next to this file. But most of them are actually on that share folder. So let's go to set test ID, and what this does is every method that will be a visitor. First of all, in this case, it's exported as like an enter, right? In this case, we could also be exporting a leave. We don't do it here, and every node gets the node, the parent, and the state. And in that way, we can traverse the tree and do whatever we want. So in here, for instance, we just say at this point that we try to understand what is the current test ID that this block should have, and we store that on the node by using the test ID property in there. So a visitor can be as simple as that, or it can be something like, for instance, the block name, right? That has a bunch of other complexities, and the block name does some reasoning about blocks, understands stuff around should this be a dynamic block because it has scopes and a couple of things like that matter for styling on basic blocks, and then it gets to the end and it does like a render itself. So in this case, this block is actually producing code, React code at the end, and it actually produces the opening tag of a block in this case. So if this were a vertical, the name final would probably be div, right? And if it has styles, maybe it's something that gets generated above. So right, and that's really the mechanism. So I'm not gonna go through all of them, but what matters here is that like we have there is an order to them, right? And at some point, then the one that does matter is when we go into block properties. So I'm gonna like skip the others because they're mainly around things that decorate the block, like yeah, like as we said before, like getting the name, getting the when, etc. Right? Now on the properties, that's the one that actually makes a difference here. Is when we start, say, putting the props on the React components, or when we start compose or creating the style object for emotion or React Native style sheet. So each of the morpher has its own file for block properties because they do slightly different things. So that's when we separate them. But they tend to share some of these. As you can see, like we have pretty much like half of them are shared. So things that we do here are things like a bit of preparation around, for instance, style, and we go ahead and gather all the styles that the node could possibly have, right? When we leave the node in this case. And when we enter it, we set up some structure around that we need later to like do that style manipulation. And you will see that we use a lot the node, right, to store stuff. As I see it is fine because that node is a throwaway at the end of it, so we just mutate it to do different things. Now once we are after this, what do we do? Let's see. So once we are done with the styles, we potentially apply a class name, see stuff around the images, and then this is when we iterate around the properties. And if there are like different, very specific style type of properties, and then there is everything else where we just literally just like put in the prop, like render it basically like this. So we just pass it down. So that's it pretty much in terms of the morpher. Now that's the first part of the morpher, which is creating, essentially the objective of that is, for the most of it, to throw strings to render, so that we have like a string representation of the body of our React component. Now, that doesn't mean that that's the whole thing, right? We've been gathering other things here, like for instance, we'll be gathering uses, which is like, okay, so if I import a view from my view, on my view file, I import A and I'm on B, I would say that this use is A, right? It also does other things like around the use of like other libraries that we infer or we use here. So the point that matters then at the end is the other method that matters is the two components. And on two component, we actually construct the React component. So you can probably see the body here of what you see on the view.js, which is we import React, we get the dependencies, we get the styles, we get the body, we get the context, and we get the default props of the component, and then we just export it. So the body probably is the most important. Here we understand when our component can be like needs to be a class because it holds state, or like, which is the case of inputs, or it doesn't, and we can just produce a function. And we also do the same with tracking. So there is this tracking module that you can have on views that essentially allows you to hook yourself to click events or to views coming in and out, and everything's automatically. That's also appended, and you can opt out of it as well, of course, when you run your own morpher. And it's up to you how you track stuff. And yeah, so this is, there's a bit to see here. So I would say just go through it. But for the most of it is like we have a render method that joins every string on render, and at the end it just is the return of that, and then we just pass a bunch of properties like the props and maybe the context and whatever we need, the state, etc. So once we're here, then the other one that matters is probably dependencies. So in get dependencies, we construct the import statements. And at the beginning, we saw that on the watcher, we were creating like a get import function. This function gets passed all the way down here. So the view at this point can understand its dependencies with other views, basically. Okay, so, and then we start importing other dependencies that we would have and so on. And that's pretty much it. Like default props, there's nothing special about it, and context as well, not that much going on. So now the end-to-end morpher is similar in structure as well. Now, how do we run this and how do we ensure that everything is fine? So there are two types of tests. For instance, in the index, there is one inline test here that we do, and then the other one is we actually test views themselves. So we have a views file on the underscore tests folder, and these files are picked up automatically for you. So what I would tend to do if I want to support something, it would be like say, okay, I run, after installing the dependencies and everything, you run the watcher in test mode, and if you want to change something, what you would do is you do this, you would change something on your test or on your morpher. If you change something on the test, the watcher is not looking at those files necessarily to refresh, so you will need to go ahead and just press A to just run it again. By the way, we're using Jest for testing, so here you can see the difference of what changed and so on. So that's one way to go about it. And then the other way, and when you're ready with your tests, you can see the options with W. I stopped it now, but you can also press the U to update the snapshots, and then it will be good, basically, if you are happy with the results you got. So snapshots are super handy for that, to let us move really fast. Okay, so the other, I guess this would be, let's try this super handy thing that Amy did, this guide. Basically, we can go ahead here and run a specific test, like I think in this case, let me see, because I actually haven't run this like that. I think I can provide a pattern here, so I would say that this test is called action. So maybe we can do that. This will pop a node simulator here, and we can go ahead and do, what do we do now? We actually go to DevTools, and that should be there. Oh, okay. Sorry, I should have actually run in space break, I think. So it actually stops at it. You should stop at the beginning. When you do that, you get this little icon here, and it will stop at the beginning of the whole thing, right? On jest, which is probably not really what we want here. That's probably why it is like that. But if you do inspect break like that, in Node, you would actually get like a breakpoint at the beginning of your script, and then you'll be able to dive into the different bits. Probably more useful is to actually use the inspect, as the guide suggests there, and actually put a debugger somewhere. So for instance, say I'm trying to understand how text gets rendered right on this view. So I go to block, I think it was called text, I can't remember. So here, property text, right? So I'm just gonna come here and do something like, okay, put a debugger when we're on text, right? And just run this. And let's see. And here we are, right? So we stopped at that point and we can start debugging what happens, which is really, really handy to just understand, you know, what's going on. What does our state look like at this stage, right? What does the node look like? What does my render stack look like at this point? Like here we can see how our view goes getting constructed, right? It's pretty handy to do that, to understand that part. And you can put a breakpoint anywhere here on the parser, whatever you want. So that's that, I would say, as a gist of a walkthrough over the Morpher. And I hope you find it handy.